Alright, so this is Unit 6, Lesson 2, and we are going to look at, in this lesson, we're going to look at a heating curve, and then in Lesson 3, we'll look at cooling curves. And they're basically, as you'll see, opposites of each other. And for the majority of the cases, for the most part, I'd say probably 75–80%, you generally see a heating curve on the Regents exam. And occasionally you do see cooling curve, but remember, they are opposites of each other. Let's quickly run through and I'll quickly explain what's going on. In a heating curve, it's really as the name implies. A heating curve is you take a sample of any substance and in the solid phase. You put it in a container, you put a thermometer in the container, and you begin to heat it, and you record the temperature of the material over a period of time. And then you plot it, and you basically have a heating curve. It's a graph, so you're plotting the temperature versus the time, and we will do a lab on this. So if you're heating something, that is obviously going to be an endothermic process. So all of the changes that are in this particular lesson are all going to be endothermic changes. So what you're looking for is, and since they're all phase changes, you're going to see 3 endothermic phase changes. So basically, if you look at the graph down here, this is when you begin to heat the temperature. You might have thought, and let's get rid of that, you might have thought that when you take a material and you begin to heat it and just record the temperature for, let's say, 20 minutes, that the line would go something like this. It would just continue to go up. But you're going to notice that, and it's not a mistake, it does begin to rise when you heat it, but you're going to notice that there's 2 flat parts, or what they call plateaus, which in this case means that the temperature for a period of time is remaining constant twice, in this section of the graph and in this section. In these sections, its temperature is going up. Remember also that temperature and kinetic energy are the same thing. So if the temperature of the material is going up, that means the kinetic energy is also going up. And we're also interested in, especially in these sections that are flat, what's going on with the potential energy. So let's take a look at the animation, and then we'll come back to the video. Here's the
heating curve is just the temperature relationship versus the amount of heat put to a substance. Most heating curves, you're going to start as a solid, which is down here, and you're going to heat the solid up. Eventually you're going to hit a temperature, and the temperature is going to stop changing. It's going to remain the same. This is where a phase change occurs, and now it's going to be a liquid, and the liquid's going to heat up, and then it's going to hit another temperature where it stops changing, and it's going to be boiling. And after it boils, you're going to have a gas. So there's 5 segments to a heating curve. The lowest temperature segment is going to be a solid, so you're going to want to label that. The middle segment is going to be a liquid, you're going to want to label that. And the gas is the highest energy state, which is all the way up top. These plateaus right here are where phase change occurs. So the phase change between a solid and a liquid, well, that's melting or fusion. The phase change between a liquid and a gas, well, that's boiling. If you want to know the temperature of the melting point, well, just look where the plateau is, and you follow the line across, and you see it's 25 degrees Celsius. If you want to know the boiling point for this substance, you follow the upper plateau over, and you find out that it matches up to 75 degrees Celsius.
Okay, and that's pretty much it. I don't want to go through the whole thing because we're going to do that here. So here's a typical heating curve. And you should be able to take a blank heating curve like this and be able to label everything that we are going to look at on this slide. All the information we are putting down is something that you need to know. So let's go through this. As he said in the video, the first section, section AB, is always the substance as it's in the solid phase. Section BC is when a phase change is occurring, when it's going from a solid to a liquid, which he said is called melting, or sometimes it's called fusion. Notice that during this phase change, the temperature is remaining constant. Once it is all melted, it's all in the liquid phase, and the temperature during section CD is increasing. Once it hits that point D, the temperature again remains constant, which means it's another phase change going from a liquid to a gas. That is boiling. And then the last section, EF, is when it's in the gas phase. Notice again that temperature is still going up. One of the things you see on the side here is another phase change, which we don't talk about in the heating curve, but we talked about at the beginning of the year. Is called sublimation. That's when a substance goes directly from the solid phase directly to the gas phase and skips all of this stuff. That is called sublimation. And I'm not going to do the time to watch the video, but sublimation is when something goes from a solid changes directly to a gas without going through the liquid phase. So one of the things you should be able to do is, if you look at this next page, is, oops, that's a heating curve. That's an animation. I'm not going to go through that. I'm going to fill in this curve though. So what you need to do is obviously be able to do all three of these for every section of the curve. So in section AB, the kinetic energy is going up, which means temperature is going up. You might want to make note that kinetic energy and temperature are the same thing. So you should probably write up here temperature. The potential energy is remaining constant, and it's in the solid phase. During section BC, which is a phase change, the temperature is remaining constant, but the potential energy is going up. That's because during this section BC, the kinetic energy is being converted to potential energy. Section CD is another section where the kinetic energy and temperature are going up. Kinetic energy, potential energy is constant. And I'm just going to quickly run through this. And you should make sure that you have all of this copied down. And remember, you do need to memorize this. And when I say memorize, you should be able to fill in this entire table with everything that's in here. And if there's not a table, you should be able to just fill in a blank heating curve. That's what memorizing it means, and off the top of your head. So this is Unit 6, Lesson number 2, Heating Curve.